And it's in on recording. Please introduce yourself and your team, and introduce your project, and then we will have questions after that. Thank you.
Yeah, maybe Petra, you can introduce ours.
Hello, I'm Petra. I am founder of enMotive. And I started this project with Shri and Pravinya because I'm working as a designer, 3D designer in automotive industry. I also studied economics, so I have some experience in that area as well. Yeah, Shri will. I'm coming from Croatia. Now I'm living here in Munich, in Germany. So yeah, that's kind of about me.
So you are living heart of the cars in Europe.
Yes,
Yeah.
yes. Yeah, we are actually working projects for BMW Group as
Yeah.
well for some Chinese companies like FAW. We were working a little bit with NIO as well.
Yeah.
So yeah,
I
we
visited
know
their
a lot
museum.
about the cars.
They have a very nice museum, the MD.
Yes,
Yeah,
and the
yeah,
showroom as well. Here they have.
yeah, yeah. So, myself, Sridhar, I also live in Munich, and I came to Germany almost 10 years ago. And I am also a 3D designer, like Petra is. So we know how to design cars inside out. So this is our job profile. I studied production engineering. So I know how parts are manufactured and how they're put together, and it becomes a car. And now we are building enMotive. So we have developed very expensive cars, like we were part of Rolls-Royce interior exterior development projects many times. And we also have developed like cars for brands like Renault or Neo, like Petra was saying. Sometimes we also have worked with Audi. So this is our background. And Pravinya, maybe you can introduce yourself.
Hi, I'm Pravinya. I live in Bangalore, but I have 20 plus years in different industries, so including Bosch. So I was a system engineer for diesel engine at Bosch. I worked at Philips, NXP, ST Ericsson, Intel, and then in my previous company, I was India head and director for a company called KaiOS. So it's world's third largest operating system. So I was head of that. So my experience varies from different technologies. I did industrial automation, avionics, automotive in Germany, same as Sri and Petra, but a long time ago, like 20 years, nearly 20 years back. And then I worked at Philips and NXP and ST Ericsson, also in marketing, also in research for 5G, 3G, and other stuff. I also have some patents on this tech. The eSIM that you see, one of the patent was related to that. And then I worked at Intel as a platform architect for different chipset as well as for IoT based chipset. So I was a platform architect. So in some of the cricket, if you understand cricket and the world of cricket, so some sensors of us which were designed by us went into the World Cup related
Okay.
statistic calculations. Also, this is my fourth startup. First startup was together with Shri, like 8 years back, no, 6 years back. We were trying to do EV, so that's when we started collaborating. And then after that, I started another company with a friend, and then which was related to automotive as well for OBD dongles. And then another one with operating system. As I told you, we were former Firefox Mozilla guys, and then we came out and started this operating system called KaiOS, and for which I was the India head. And now, also one more caveat to that is using this mobile operating system. So we sold, my customer Reliance Jio. sold around 140 million devices in India. So that was a big achievement for me. And as well, after that, since we had lack of funding, we had to close the India site, and I moved all of my team into Reliance Jio. Currently, I'm senior director, director and chief architect at Jio, doing several projects at Jio, IoT, mobile devices, and several other stuff. So yeah, that's my background. So I do hardware, software, integration,
Yeah.
everything around that, cloud, IoT, all that. So yeah, that's my experience.
Very good.
So, and hello, I say, and Tanner. So good to see you as well.
Thank you. Hello.
Hello.
So maybe I can run all of us through our latest pitch deck. That will be the idea. So please have patience for 10-15 minutes for this pitching. Maybe I will switch off camera so that we can have a bigger bandwidth.
If you, I can at the same time I can share your presentation, or you can share if you want.
Yeah, we have some updates after that. So
Okay.
better with that.
You can send us this updated document.
Yeah, we can. So
And by
as
the
you
way,
see,
before you start, we really love the design because of both of you designer and my brother is architect. Really,
oh,
it
nice.
is nice design. Sorry for interrupt.
Well,
Thank
thank you for your comments. We are excited to hear this. So just last week, we heard that Volkswagen is going to shut down some factories in Germany because they are feeling stiff competition from Chinese EV brands in terms of quality also and in terms of cost also. So we realized that in Europe, there will be demand for economical EVs, because if you want to buy EVs, they're very expensive. So that's where we don't want it to go. And because I come from India and I have seen a lot of three-wheelers transportation. I mean, India's entire cargo and I mean, city cargo and people transport is based on three-wheeler taxis and pickups.
They are
And
lifesavers
same is
in India, Indonesia, these are their lifesavers.
yeah. And in Europe also, I mean, in Germany where I live, I see three-wheelers, but those three-wheelers are like very old. Maybe they came to market 20, 30 years ago. So farmers, they bring a lot of their fresh vegetables with small vehicles on German small towns, big cities, city centers. In Croatia, where Petra grew up, there also she realized that there will be demand for small EVs, no, which are not expensive, and that's why we went to design this kind of EV, which appeals to European customers as well as customers from developing markets also. So we have a design certificate from European Union Intellectual Property Office for this design now. And so we have developed a platform basically, and based on platform, it can be a passenger vehicle or can be a pickup truck also. At the same time, we also wanted to bring little fun factor, little style to this vehicle, and that's why we are branding or designing, engineering, promoting, marketing it as a lifestyle vehicle as well. Because if you go to big European cities, in city centers, you can see this kind of small tuk-tuks used as a tourist taxis. And yeah, this is the slide which perhaps I had not mentioned in our pitch deck. So we are engineering EV 5.0. So what is EV 5.0? So Tesla came to market maybe 15 years ago. 2011 they launched Tesla Model S, but Tesla Model Y, which was launched in 2020, based on gigacasting, is EV 5.0, and it's a technology which Tesla invented in 2019-20 itself, and now Chinese EV brands have mastered this technology. It's a manufacturing technology, and because of which they can produce EVs much cheaply than the conventional way of manufacturing. And this is why we are saying that we are engineering EVs for EV 5.0 technology. So this is EV 5.0. So Tesla Model Y. So on the screen, you see Tesla Model 3, which is the older version, and Tesla Model Y, which is a newer version. So you can see these colors, small colors, different colors. Each different color is an individual component which was manufactured differently. With Tesla Model Y, they managed to combine all these small parts into big part with gigacasting technology, and thus number of parts in the vehicle have reduced to just 2 pieces from 171 pieces. As a result, you don't need as many robots on manufacturing line. You don't need as many movements of parts from one welding station to next welding station, and thus there will be huge reduction in capital infrastructure to build a factory.
And
That's
speed,
why,
of course, it will be
yeah,
faster.
exactly. And Chinese companies, they adopted instantly. So just 3 months ago, Xiaomi SU7 was launched in Chinese market. This vehicle is as big as Porsche Taycan, which is bigger than Mercedes S-Class. But in Chinese market, they have the lowest variant they have managed to launch at 30,000 US dollars, which is very cheap, which is like 1/3 the price of Porsche Taycan. So this is the innovation. But of course, to manufacture this kind of EVs, you need to know how to engineer those kind of EVs, and that's what we are doing, because we come from this kind of, we have seen similar engineering processes with some Chinese, and so now BMW, Mercedes, they are investigating how to engineer their vehicles for this kind of manufacturing processes. So this is how we have pivoted our manufacturing technology. And as a result, we can command now 50% profit per unit sold, having this vehicle engineered, and in the future if we manufacture with this technology. Conventionally, in automotive industry, if you look at profitability, company like Suzuki, Toyota, they have 7%, 10%, 12% profit per car they produce. If the car is more expensive, like Porsche or BMW, then the profitability per unit increases because they are selling much more expensive technology. But now with gigacasting technology, we can reduce cost of production, and we can sell our vehicle in the price brand where our competitors in this segment are selling, which is 15,000 units per unit. And this is the advantage which gives this gigacasting. Now we are part of Move Plus Startup Accelerator. This startup accelerator is managed by City of Friedrichshafen, where Zeppelin University is registered or does exist, and also part of it is also managed by ZF. So we are now getting mentored by Manuel from ZF. So ZF is world's third largest manufacturing auto component manufacturing company. So our association with them started just 2 months ago. So on every week or every 2 weeks, we are having mentorship calls with ZF. And this is the founding team. We already gave a brief introduction about founding team. And we are also from time to time getting advised by Paul. So Paul in the past developed this kind of a small vehicle like 10 years ago when EVs were just coming to the market. So for this kind of a vehicles, he developed swappable battery technology. So he's our one of chief advisor. And now to put together physical prototype, we have partnered with Roding Mobility. So they are helping us with further calculation, how to put together different parts, how to take the first prototype to the market, and from first prototype, how we can engineer vehicle for mass manufacturing. So this kind of support he's giving us from time to time. Yeah, on this slide, you basically see, so the vehicle which is in black and yellow is world's largest selling three-wheeler. So we engineered our vehicle in similar specifications so that we get similar type of certification for road usage and for manufacturing. So, yeah. And when it comes to powertrain engineering, we benchmarked a Taiwanese company called Gogoro because they are the one who have swappable batteries in their scooters, and they have launched their scooters in European markets also. So in Munich also, we see many Gogoro scooters, but they are on mobility platforms. Individual buyers cannot buy them in Germany. In Taiwan, individual buyers just buy scooter and goes to swap station and swap batteries. So we benchmark similar specification for our vehicle so that in future we can either partner with Gogoro, or we can give option to individual buyer just to take out their battery, bring them home and charge overnight. And then next day you get range of around 150 to 180 kilometer with 4 batteries. So, and again, we looked at world's largest selling three-wheeler. They have launched their EV as well, and you can see here that in their EV engineering, there is no floor space because the entire floor is now covered with battery and other electronic parts. But our EV is more spacious inside because we have smaller two motors in the rear, just like Tesla model. Many Teslas have three motor or two motor configurations. So this is our engineering for powertrain. Yeah, and we felt that we need to engineer this kind of vehicles because they evolved basically from a scooter platform 75 years ago. Scooter slowly became a cargo transport. Then they converted that cargo transport to passenger vehicle. And more or less, even now, the overall vehicle package has remained the same, even after electrification. So we feel that there is need to re-engineer the entire platform, just like Tesla did. I mean, 100 years ago also there were EVs, but Tesla was the first company who re-engineered everything, not just only batteries and motors. The entire vehicle architect they changed, and that's what we are doing with the three-wheeler industry. And these are the USPs, like for the similar exterior dimensions, we are more safer. We have all-weather proof protection. Like because of similar size and dimensions, we are in same tax classes all across countries. In Germany also, this vehicle falls under L5 vehicle certification criteria. In India also L5. So the maximum speed in this category is 50 kilometer per hour. It is for city use. It's not for highway purpose. Moreover, it's affordable, and we also wanted to make it look cool and aspirational. Also, when you look at the interiors, we are more comfortable. You can see how ample leg room you have, how comfortable a driver can go. Even you can carry tourist suitcases or bags in more efficient way. We are basically utilizing our floor space more efficiently. And that's why we say that we have flexible real estate. There are a couple of slides, maybe. So there are a couple of variants actually, which we can use as a real estate on wheels. Maybe that slide was in your pitch deck, which we shared with you. Or there is possible, it's possible to take out the front wheel, take out all the electronics like batteries and motors, and this vehicle, remove all the seats, and this vehicle becomes a small caravan. So we are making our market bigger by addressing caravan market as well. I will show a couple of slides on that in some time. And also we are using, because we are a surface designer, the founding team know how to do 3D design. Our entire organization is like VR centric. We can work with VR in design and R&D. We can utilize VR for training shop floor workers, and we can use VR for marketing and sales also. So this is our strategy. And yeah, so this slide basically shows that we were on the streets, we were talking to various users and we're taking feedbacks from them. And if we look at the business aspect, let's go through the competition first. So we have identified some competitors in Europe also and in India also. So in Europe, we have identified eTook Factory, Clean Motion, and Muzoshi. So these are like 3 European companies selling in European market, and they're selling in the price band of around 16,000 euro to 28,000 euro. And for similar specification, like exterior dimension, motor, battery capacity, the Indian players, they're selling 4 times cheaper. But in India, the advantage is that the market is 100 times bigger. So we were designing our vehicle by benchmarking these competitors when it comes to price, engineering specifications, and it's possible for us now to sell in both markets depending on different variants. In Europe, the product market fit would be like logistic companies. We see a lot of postal companies, Amazon, they bring your packages to you by means of vans, like these big vans. They're electric and they're very expensive. Like one from Volkswagen or Ford cost around 60,000 euro, and it's very expensive. Or you get your post on bikes, but these bikes, they cannot lift heavy cargo. They are also not weatherproof. And in many countries now, dedicated bike lanes are now allowed only for pedestrians or bikes, not for cargo vehicles. So that's the disadvantage we see. In Europe, there had been many cases that these trikes, they just put like 300 kg weight on it and they drive into bike lanes. And if they crash into bikes, then the bikers get heavy injury. And there had been many deaths as well. So we are exactly in between these two segments, and this is where we see product market fit for us in Europe. It can be a van carrying parcels, or if you want to carry heavier load, then we have another option, heavy load like washing machine or refrigerator. So for that, we have another variant, which is pickup variant. Or in Europe, like tourist taxis, they can use our passenger variant. Or if we have to sell in developing countries like India or African markets, we can strip down the variant. Like, for example, in African markets or Indian markets, doors are not mandatory. So thus the vehicle price goes down, and thus we can compete with our competitors in those markets. So this is the strategy. Our largest competitor is Bajaj. It's from India. Basically, they took license from Piaggio, Italy. Piaggio is the one who invented these three-wheelers 75 years ago. Bajaj took license to manufacture these vehicles in India, and now Bajaj produces 4,000 units per day. Their production capacity is that much. Apart from India, China is also one of the biggest markets for three-wheelers, and Chinese market is more about cargo vehicles than passenger vehicles. So this is the market size we are addressing. And here on this corner, you see a brochure from Piaggio, Italy. So they are selling these small three-wheelers. They are not electric. They are benzene, and their unit price is around 7,500 euro. So there is a considerably big market for three-wheelers in warmer European countries like Italy, Spain. In Germany also we see them often in small villages. But they are not, they are like old vehicles. So in Europe, it's possible for us to create a new, bigger market because we have engineered a three-wheeler for 21st century. It's not 75-year-old design. And our business model is basically either we work with logistic companies in B2B segment, or we can sell directly to end customers. In India, for example, a lot of drivers own these vehicles individually. It's like their family vehicle. Also, yeah, here you can see if you take out the front wheel and all the electronics, then this vehicle becomes a caravan. So that's why we can address caravan market, which is huge in Europe, but conventional caravans are very expensive. If you want to buy a new trailer caravan, the prices could be anywhere between 20,000 to 100,000. But because now we have dual purpose vehicle, we can reduce the price of this vehicle to 5,000 euros also. Or we can get into caravan rentals, like based on your weekly or yearly need, based on per day basis, people give us some rent and we sell, we rent them caravans.
Okay. If we can finish very quickly, we need to have some questions,
Yeah.
if you don't mind.
So that was basically the last slide, and the next slide is about how we are putting our factory plan. So what are the things which we need to manufacture within our factory, and what are the parts which we need to bring from suppliers? Based on that, we have a micro factory because now we have turned to giga casting. So basically, one giga casting machine can produce all our metal parts, like metal parts like floor, front metal part, rear metal part, the roof, and thus our factory becomes micro. So we can produce like 10,000 units per year in this micro factory, and depending on demand, we can have similar unit, or if there is no demand, basically we shut off all suppliers and we use our factory setup and become vendor for other manufacturers who need aluminum parts. So this is our micro factory setup. Yeah, and basically this is end of our short presentation.
Okay, thank you
Thank
so
you.
much. My first question is from the presentation and the pitch deck, I couldn't get the where are you planning to establish the manufacturing as a region? Have you identified any specific country or region where production will be take place, or you exploring partnership with existing manufacturing facilities?
We have some thoughts about it, but we haven't finalized our plans yet because we need now funding to manufacture the first prototype. And that's why we have not finalized our factory plans. But because our main market, first market is Europe, where we want to sell our first 10,000, we would like to have first factory in Europe. So we have spoken with some people who are already into manufacturing, and they said that they can offer their factory because some part is staying vacant. So one guy we spoke to is in Germany itself. Some people, advisors suggested that if you go to Eastern European countries, manufacturing will be cheaper and you will get a lot of incentives as well. So country like Greece or Croatia or someone from Greece, in fact, was proposing us that we can manufacture in Greece and they become our partners for manufacturing.
Okay, because if you are planning to do it in India, there will be tax issues, there will be different issues. So you are mostly planning for EU, right? Then as
The first factory will be EU. Tax issue, I mean, even if we manufacture in India, there are benefits like the labor cost is cheap there. If we manufacture in India and export to Europe, then we will have to pay 10% import tax above the vehicle price.
Mhm.
But the benefit of producing in India would be that we can
More.
scale 10 times higher as well.
Exactly.
Yeah.
And when you produce it in manufacture it in India, what will be the approximately cost?
Yeah, so we did some basic cost calculation. We have not gone to suppliers to ask for each and every part. We source all parts and their cost from open internet source. Like if you go to Alibaba Express, you get prices for batteries, for motors, and now we have a CAD data for the entire vehicle. So it's possible for us to estimate the weight of the vehicle, for weight of the plastic, weight of the metal, and we know how much in the what are the economics of giga casting. So based on that, we did calculation, and our production cost is coming to around 2,800 euro per vehicle.
Because in production vehicles will cost really related with scaling. So
Yes.
if you have not good capacity, then the costs higher. You have to find the optimum scaling. It doesn't mean that when you produce more it is cheaper, so there is an optimum amount. So did you count it? Did you scale manufacturing? How much do you plan to product this product to make the optimum cost and the sales per
Yeah, so
year?
basically we are talking now about break-even
Yeah, break
calculation.
even, exactly.
Yeah, so we know how much we need funding to develop the first prototype. We have some figures about developing this prototype further for pre-production prototypes and then the final factory price. So based on that, we realized that if we sell 18,000 units, 18
Mm-hmm.
units, then we would break even. That would be roughly 1.5 year after we start selling the vehicle.
Mm-hmm. Mm-hmm. I mean, it's because you have different kind of types cargo. Especially when the Uber guys or Bolt guys decide to work with you, then you cannot just you can work just for them.
Yeah.
So but when you make that counting in Europe, what will be the cost instead of
In
2000?
Europe, the showroom price will be 15,000 euro.
No, I mean production price.
Production price, yeah. The production price in Europe, our based on bill of we still don't know the labor cost
Yes.
and energy cost, but we calculated the component cost,
Yeah.
and
Okay.
that comes to around 2,800 euro.
Okay. And actually, one of our mentors specialized on EV vehicles. So actually, we need her opinion mostly because this is a special area.
Yeah.
So we will share this presentation with her too, and her opinion is most important for us
Yeah.
because she is the best person in Poland and Europe, one of the important person in this area. And I want to ask about because normally we passed already, but I want to ask about especially batteries.
Mhm.
Uh, I already prepared my question here.
Okay.
Because you said that you can swap the batteries,
Mhm.
right? So what will be the for example, can you explain that how you plan that charging and swapping stations?
We are not planning charging stations.
Mm-hmm.
We don't want to go in that business.
Mm-hmm.
What we are saying that it's possible to take out the battery from the vehicle and charge it by
At
yourself
home.
in your house.
How many kilowatt will be one battery, and how many battery will be in the vehicle in your design?
So there will be a solid state LFP battery. it will be one battery will weigh around 9 kg,
Mm-hmm.
and in 9 kg battery there will be around 2.5 kilowatt hour of battery capacity, and we will have minimum space for 4 such batteries.
Mm-hmm.
And based on this battery configuration and motor configuration and vehicle weight, this vehicle can give speed up to 160 kilometer range. So it's enough for 1 day drive for a commercial vehicle.
It's better than my Volkswagen now. My Volkswagen, in this presentation, there's a two people has an electrical car, and
Okay.
mine was in a. I mean, it says the first model of the Volkswagen. They produced in a old way. It's not a really in 2016 production. So I can go maximum 135 kilometer. So
Oh, really?
yeah, as soon as you have it, I want to swap with yours.
Okay. Yeah, I mean, the competitors which we showed you in the presentation, they have range of around 150 minimum. Some models can go to 220 because these are light electric vehicles. These are not heavy electric vehicles. So that's why you can achieve this range.
So the most efficient thing is that you can swap the batteries. So if you have extra 4 batteries at home, even you can carry your batteries with yourself too, maybe. So it's you can make it more than 160 kilometers by changing batteries. Okay. So the from the team, is there any questions? I will check my questions. By the way, you other people can ask questions.
The questions are basically what are the terms and conditions if we decide to engage further? That would be one question. Because I filled this application via F6S
Yes.
web portal, and I think we would need more information about further engagement.
Sure. Of course. And last questions from our side. So you mentioned that you started that project in 2023, and you have a pre-seed 2.5. Did this approved, or you just apply for that one 2.5 million euro pre-seed?
No. We need 2.5
You needed
million.
that. Okay.
Yeah.
Okay.
Yeah.
So for first prototype, you need 2.5 million, right?
So our target is that with 2.5 million euros or roughly 3 million US dollars, we would develop a drivable homologated prototype, which we can drive on a public street. So when you drive on public streets, you need special certificates for safety.
Yes.
So with first prototype, we can achieve this safety criteria, and we would need roughly 9 months to build this prototype.
So after that prototype, production cost, what will be the factor cost roughly? Did you count it about that one?
So there will be, so in vehicle development, there are roughly 3 technical development stages. First one is first prototype. The second one is taking the engineering further and make it suitable for mass manufacturing. So in this stage, we would need roughly 20 to 30 million euros. We don't have exact estimate because then in that stage, we will have to negotiate with maybe 20 different suppliers for different costs. So in the first year, when we start building our first prototype, we will already engage with the next suppliers, which will come at the mass manufacturing. So their prices and quotation will be very different that time. And that's why we will need roughly 1.5 to 2 year more to develop further stages of engineering. And by end of third year, we can start manufacturing this vehicle, provided that our factory is also ready in between. For that factory, so 1 gigacasting machine as of now cost around 6 to 20 million. We went through some documents. So for one machine itself, 6 to 20 millions, and then you need further machines for few welding machines, few welding robots, painting facility. So if you calculate cost from first prototype until factory, that would be roughly 90 million.
Almost 100, yeah.
Yeah.
But actually, if you sell 18,000 units per year, if this will be look right, I think
So
you,
yeah,
your
our
revenue.
production capacity planned is 10,000 units per year. So 10,000 units and unit price is 15,000 euro. So our revenue in the first year of production will be 150 million.
But
And when
your break even is 18,000.
in the second year, basically, we will break even.
Okay. So first, of course, it's in. So okay. So with your question, because we already limited time now,
Yeah.
with your question, what we do when we support your project with 10,000 euro, of course, we have some requests about maybe you read that about that because you already, I think, but we want to mention it again. When we support that 10,000 euro, we ask 5% of the company. And what we want, of course, this is a conditional supporting. We want to spend that money not for marketing, not for, of course, it could be marketing too, but the mainly to tools that we can find bigger investors. Because and we will ask you to spend that money to maybe, because as a design there is no problem, maybe from technical side or from economical side, so when we go to the investors to convince that investors what we should do with mentors, with the consultation. So actually we are helping you to find you more bigger league and bigger investors. So that will be the this money will go for that one.
Okay.
Do you agree on that?
Yeah,
Okay.
this sounds good. Yeah.
Okay.
Sounds good.
Yeah, so we will again, as I said, we will consult our mentors who are expert on that area. Actually, we have another project. It's a not car, but still electrical vehicle. So we need to consult their opinion, and
Yeah.
we will let you know as soon as possible. During that period, you can provide extra any documents what you wanna provide. This latest presentation you can provide if you wish.
Yeah.
It could be from the system or from the LinkedIn, whatever you want. And these are my questions. And thank you for your time. If any other questions you have, you can ask anytime.
Only
Yeah.
one small question, if I missed or I don't know. Do you know legal obligations to use? Do you need a B class driver license or only motorcycle license?
Like 16 years old in Poland or Europe, generally in 16 years old, they can use electrical vehicles without license, as far as I know, but I don't know the other Europe. In Poland, this is the rule.
You made a search, I think, so you
Yeah.
know.
So this vehicle falls under LEV category. So LEV is light electric vehicle. That's a European certification criteria for vehicles. And depending on country, the driving license requirement change. For example, the vehicle which I showed from Piaggio has a 50cc benzene engine.
Yeah, I
For
saw that
that,
you're right, 14 years old, right? It was interesting.
yeah, for that, in Italy, they can drive at the age of 14 with A1 license. In Germany, you need to be 16-year-old and you need a teenager license A1. In Sweden, we came across a tractor category. So these vehicles So in Sweden, we were told that rich parents buy Porsches, new Porsche, for their teenager drivers, because Sweden is big country and they don't have good enough public transport. But then they need to register this Porsche as a tractor.
Okay.
And in tractor category, they need to give access to only 2 passengers. That means driver and co-driver, and they cannot carry load. And the
Mm.
vehicle speed also need to be restricted to 50 km/h. And then those kids can drive in Sweden from the age of 15. I'm not sure exactly.
Okay.
With Porsche 50 kilometer, it doesn't make. I don't believe it, but
Yeah.
Okay. Thank you very much.
yeah. So
Thank you
it
very much.
depends on
It
the
was very
country.
impressive. Thank you very much.
Yeah. Okay, it is very, as we said, that we love the design, and it looks, and especially from my perspective, of one of our members, working with Alibaba in Poland, and actually they are working with that carriers. So we will show him that project, him too. So let's I cannot say more about that one because I need to
Yeah.
manage the meeting. So our other team members will give you the points, and but I already love the design and the logic. Thank you so much, and I
Thank
believe that
you.
this will work.
Yeah.
Thank
Thank
you.
you, everyone.
Thank
Thank
you so
you.
much.
Thank you very much. It was a pleasure for us in the name of my team. We are very glad to meet you. Thank you very much, and hope success. Thank you very much.
Yeah.
Thanks
Thank
so
you
much.
very
Have
much.
a great day.
Congratulations.